Imagine looking up at the night sky. You see stars, maybe a planet or two shining brightly. For most of human history, we knew of only a handful of these wandering lights. Mercury, Venus, Mars, Jupiter, and Saturn. They were our solar system. Then telescopes grew stronger, and our cosmic neighborhood expanded. We found Uranus in 1781. We found Neptune in 1846. The solar system seemed complete, but astronomers suspected something else was out there. Something was tugging on the orbits of these distant giants. A hidden world, a mysterious planet X, was waiting to be found. This hunt for a ninth planet captivated astronomers for decades. It was a search filled with painstaking work and many false leads. They scanned endless photographic plates, looking for a tiny, moving dot against a sea of stationary stars. It was like searching for one specific grain of sand on an enormous beach. The challenge was immense, requiring patience and incredible precision. The calculations were complex, the observations tedious. But the thought of finding a new planet, of adding another member to our solar family, was a powerful motivator that kept the search alive and fueled the dreams of many. Then, in 1930, it happened. A young astronomer named Clyde Tombaugh, working at the Lowell Observatory in Arizona, finally spotted it. He had found the elusive Planet X. It was a faint, small point of light moving ever so slowly through the constellation of Gemini. The world celebrated. A new planet had been discovered, the first one found by an American. It was a monumental achievement. The solar system now officially had 9 planets. This discovery was a testament to human curiosity and our relentless desire to understand the universe around us, to map out every corner of our celestial home. This newly found world needed a name. Suggestions poured in from all over the globe. The name that was ultimately chosen came from an 11-year-old girl in England named Venetia Burney. She suggested Pluto, the Roman god of the underworld. It seemed fitting for such a dark, cold, and distant world, orbiting so far from the sun's warmth. The name was perfect, and so Pluto officially took its place as the 9th planet, the final sentinel guarding the edge of our known solar system. For over 70 years, this was the story we all learned and accepted without question. For a long time, Pluto was a mystery. It was so far away and so small that even our best telescopes could only see it as a fuzzy dot. Scientists thought it must be quite large, perhaps even bigger than Earth. This initial assumption was based on the gravitational effects it was thought to have on Neptune and Uranus. The math seemed to suggest a world of significant mass was required to cause such disturbances. This belief in a large Pluto was a key reason why it was so easily accepted as a full-fledged planet, fitting in with the other giants of the outer solar system. But as our technology improved, a strange thing began to happen. Pluto started to shrink. Not literally, of course, but our estimates of its size kept getting smaller and smaller. With each new measurement, the 9th planet seemed less and less impressive. Astronomers recalculated the masses of Neptune and Uranus and realized the supposed gravitational pull from Planet X was just a measurement error. There was no need for a massive planet out there. Pluto wasn't a giant hiding in the dark. It was something much, much smaller than anyone had ever imagined. The discovery of Pluto's largest moon, Charon, in 1978, gave us the best measurement yet. By studying the orbits of Pluto and Charon around each other, scientists could finally calculate Pluto's mass accurately. The result was shocking. Pluto was tiny. It was far less massive than even Earth's own moon. It was a celestial lightweight, a dwarf among giants. This discovery was a major blow to Pluto's status. How could a world so small be considered a true planet, in the same league as colossal Jupiter or Saturn? The puzzle of Pluto was becoming more complicated. This shrinking perception of Pluto planted the first seeds of doubt in the minds of astronomers. The story we had told ourselves for decades was starting to unravel. Was Pluto really the grand finale of our solar system, or was it something else entirely? The 9th planet was no longer the big, important world we once thought it was. It was an oddball, a misfit that didn't quite seem to belong. The questions were starting to pile up, and the scientific community was on the verge of a major debate that would change how we see our solar system forever. Doubts about Pluto grew with the discovery of its strange orbit. Unlike the other planets, Pluto's orbit is tilted and very oval-shaped. It behaved less like the other 8 planets and more like objects in the far reaches of the solar system. This odd orbit even causes Pluto to cross the path of Neptune. Then astronomers discovered many other objects out beyond Neptune in the Kuiper belt, some almost as big as Pluto. The discovery of Eris, which was even more massive than Pluto, was the final straw. This discovery forced us to reconsider everything and rewrite the story of our solar system. A big decision was coming. Our story begins not with a discovery, but with a puzzle, a cosmic mystery. In the late 19th and early 20th centuries, astronomers had a beautiful and orderly picture of our solar system. They knew about the 8 planets, from Mercury all the way out to distant Neptune. They could predict their movements with stunning accuracy, using the laws of gravity laid down by Isaac Newton. But there was a problem. Something was not quite right with the orbits of the outermost planets, Uranus and Neptune. They seemed to wobble. They strayed from their predicted paths, as if something unseen was gently pulling on them from the darkness of deep space. This was a tantalizing clue, a ghost in the machine. Many astronomers believed that the only explanation was another planet, a 9th one, lurking unseen beyond the orbit of Neptune. They called this hypothetical world Planet XX, representing the unknown. The hunt was on. One of the most dedicated hunters was a wealthy Bostonian astronomer named Percival Lowell. He was convinced that this planet existed. He founded an entire observatory in Flagstaff, Arizona in 1894, partly for this specific purpose. The Lowell Observatory became the epicenter of the search for this mysterious, distant world. The task was monumental. Planet X, if it existed, would be incredibly far away and therefore incredibly faint and slow-moving. Finding it would be like trying to spot a single firefly crawling across a vast, dark mountain from miles away. The method was painstaking. Astronomers would take long exposure photographs of a small patch of the night sky. A few nights later, they would take another photograph of the exact same patch. Then, they would compare the 2 images, looking for any tiny dot that had moved against the fixed background of thousands of stars. It was a grueling, mind-numbing process that required immense patience and dedication. For years, Lowell and his team scanned the heavens. They calculated, they photographed, they compared. But Planet X remained elusive. Lowell himself died in 1916, never having found his prize. His calculations had pointed to several possible locations, but the search had yielded nothing but frustration. It seemed the ghost would remain a ghost. The solar system's biggest secret was well kept. But the dream didn't die with Lowell. His legacy, the Lowell Observatory, continued the search, driven by the belief that a new world was out there, just waiting for a patient pair of eyes to find it. The search for Planet X aimed to prove our understanding of the universe and the laws of gravity. When Uranus's orbit showed strange wobbles, astronomers predicted another planet's existence. The discovery of Neptune was a triumph. When Neptune wobbled, history seemed to repeat itself. Another planet, Planet X, must be pulling on Neptune. This fueled Percival Lowell's quest, performing complex calculations to locate this unseen world. The search was difficult, the data noisy, but the potential reward was too great to ignore. The team at Lowell Observatory continued the systematic search, building a new telescope for the task. They aimed to complete the map of our solar system and confirm gravitational theory. Clyde Tombaugh, a young man from Kansas, had a passion for the stars. He built his own telescopes, grinding the lenses himself. In 1928, his drawings impressed astronomers at the Lowell Observatory, who offered him a job to search for Planet X. Tombaugh used a blink comparator, flipping between photographs to find moving objects. After months of meticulously scanning millions of stars, he persisted. On February 18, 1930, he found a tiny dot that jumped. It was moving slowly against the stars. Planet X had finally been found. The 24-year-old farm boy had changed our map of the universe forever. The discovery was a sensation. The Lowell Observatory, after carefully confirming Tombaugh's finding, officially announced it to the world on March 13, 1930. The date was chosen specifically because it was both the anniversary of William Herschel's discovery of Uranus and Percival Lowell's birthday. Newspapers around the globe ran front-page headlines celebrating the discovery of a ninth planet. The solar system had a new member. It was a moment of immense pride, especially for American astronomy. For the first time, a planet had been discovered from the United States, a testament to the nation's growing scientific prowess. Now, this new world needed a name. The observatory was flooded with suggestions from the public. People suggested Cronus, Minerva, Zeus, and even Percival or Lowell in honor of the man who started the search. The observatory had the right to name the planet, and they wanted a name that fit with the tradition of naming planets after Roman and Greek gods. The name had to be just right for a world that was so remote, so dark, and so cold. It had to evoke a sense of mystery and distance, a world dwelling in the perpetual twilight at the edge of the sun's influence. The winning suggestion came from an unlikely source, an 11-year-old girl from Oxford, England named Venetia Burney. She was fascinated by classical mythology. One morning, her grandfather, who was a librarian at the University of Oxford, was reading the newspaper story about the new planet. He mentioned that it still needed a name. Venetia, thinking about the dark and gloomy world so far from the sun, suggested Pluto, the Roman god of the underworld. Her grandfather thought it was a brilliant idea and passed the suggestion along to an astronomer friend, who then cabled it to the Lowell Observatory. The astronomers at Lowell loved the name. It was perfect. Not only did it fit the mythological theme, but the first two letters, PL, were the initials of Percival Lowell, a fitting tribute to the man who had dedicated his life to finding it. On May 1st, 1930, the name was officially adopted. The world was introduced to Pluto, the ninth planet. For the next 76 years, every schoolchild would learn its name. Every textbook and every model of the solar system would include this small, distant world. Pluto's place in our cosmic family seemed secure, a permanent fixture in the celestial lineup. For decades, Pluto was the ninth planet, a mysterious frozen world. But as our technology improved, Pluto began to shrink as scientific estimates of its size kept getting smaller. The discovery of Pluto's moon, Charon, allowed scientists to calculate Pluto's mass accurately. The numbers revealed Pluto was an absolute lightweight, far less massive than anyone thought. This tiny, icy world suddenly seemed out of place. This shrinking of Pluto planted the first serious seeds of doubt about its planet status. It was something much more peculiar, and its identity crisis was only just beginning. Pluto's behavior was also highly unusual. If you imagine the solar system as a flat disk, all the major planets orbit the sun on this same plane in nearly perfect circles. But Pluto is a rule breaker. Its orbit is wildly different, suggesting it might belong to a completely different family. Pluto's orbit is highly inclined at a steep angle. Furthermore, its path isn't a neat circle. It is highly elliptical. For a 20-year period, its path actually brings it inside the orbit of Neptune. No other planet in our solar system has an orbit that crosses the path of another. For every 3 times Neptune orbits the Sun, Pluto orbits exactly twice. It behaved less like an independent planet and more like an object controlled by its giant neighbor. The case against Pluto was steadily building. For more than 60 years after its discovery, Pluto was the king of the outer solar system. It was the only known object beyond the orbit of Neptune. This solitude was a key part of its identity as a planet. It seemed to reign alone over the vast, dark expanse of space at the edge of our sun's influence. But that all changed dramatically in the 1990s. Advances in telescope and camera technology allowed astronomers to peer deeper into this dark region than ever before. What they found would not just question Pluto's status, it would completely transform our understanding of the solar system's structure. In 1992, astronomers David Jewett and Jane Liu discovered a new, small, icy body orbiting far beyond Neptune. Its official name was 1992 QB1. It was tiny, much smaller than Pluto, but its existence was a bombshell. It proved that Pluto was not alone. It was just the first member of a whole new population of objects that had been waiting to be discovered. This region of space, a vast belt of icy debris left over from the formation of the solar system, had been predicted decades earlier by astronomer Gerard Kuiper. Now, we had proof. The Kuiper belt was real. Suddenly, the floodgates opened. Following the discovery of 1992 QB1, astronomers started finding more and more of these distant objects. Dozens, then hundreds, then thousands of them. It became clear that the outer solar system was not an empty void with a single planet. It was a crowded, bustling neighborhood, a cosmic junkyard filled with countless icy bodies, which we now call Kuiper belt objects or KBOs. Pluto, it turned out, was not a lonely king. It was simply the largest and first to be discovered resident of this massive icy swarm. This discovery fundamentally changed the context in which we saw Pluto. This new context was deeply problematic for Pluto's planetary status. If Pluto was a planet, then what were all these other objects? They shared its icy composition. They shared its region of space. Many of them even had peculiar tilted orbits just like Pluto's. The line between planet and not a planet was becoming increasingly blurry. Pluto started to look less like a unique and special world and more like the biggest example of a very common type of object. It was like realizing the special, unique rock you found was actually just the largest piece of gravel in a very long driveway. The discovery of the Kuiper belt put Pluto in an awkward position. It was now the largest member of a vast swarm of icy bodies. The search of the Kuiper belt was yielding bigger discoveries. Astronomers were finding objects getting uncomfortably close to Pluto's size. The discovery of Eris was the tipping point. It threw the world of astronomy into chaos. The public and scientific community faced an unavoidable dilemma. If Pluto was a planet, then Eris surely had to be a planet too. A clear definition of the word planet was urgently needed. The International Astronomical Union knew it had to act. They scheduled a historic meeting in Prague. The fate of Pluto was about to be decided. In August 2006, hundreds of astronomers gathered in Prague for the International Astronomical Union's General Assembly. On the agenda, to officially define the word planet. The discovery of Eris, more massive than Pluto, forced the decision. Two factions emerged, one arguing for a more inclusive definition based on physical properties, the other for a more exclusive one, requiring a planet to dominate its orbit. The debate raged, passions ran high, and the fate of Pluto hung in the balance. Astronomers needed a clear definition of planet. The old list was getting out of hand. A committee drafted a new three-part test: orbit the sun, be round from self-gravity, and clear your orbital neighborhood. The first two rules were easy for Pluto. It orbits the sun and is spherical. But the third rule, clearing its orbit, was the deal-breaker. Only the 8 classical planets passed all 3. Pluto, surrounded by Kuiper belt objects, failed the last test. The new rulebook would change Pluto's status forever. On August 24, 2006, astronomers gathered for a historic vote. The new planet definition passed, and Pluto was officially demoted. Pluto didn't clear its orbit, so it lost its planetary status. A new category, dwarf planet, was created for Pluto, Eris, and Ceres. The news spread fast, sparking public outcry and debate. Pluto, once the 9th planet, became the first of a new class. Many mourned the loss, but the solar system's map was redrawn. The controversy over Pluto's fate was just beginning. The term dwarf planet was meant to clarify, but it confused many. Unlike dwarf star, a dwarf planet isn't a planet at all by IAU rules. This new category recognized Pluto's complexity. Spherical, geologically active, with moons. Pluto, Eris, Ceres, Makemake, and Haumea joined the club. Still, many scientists and the public disagreed with the IAU's definition. For them, Pluto's roundness and unique features matter more than its orbit. The debate over what makes a planet continues to this day. The IAU's 3-part checklist for planets is strict. First, orbit the sun. Second, be round from self-gravity. Pluto passes both. Many argue these 2 rules should be enough. But the third rule, clearing the neighborhood, excludes Pluto. Planets must dominate their orbits. Pluto doesn't. The 8 planets are gravitational masters. Pluto is not. This controversial rule redefined our solar system. Pluto's journey as a planet ended here. Pluto's downfall was its crowded home, the Kuiper belt. It shares its orbit with countless icy bodies, unlike the 8 planets. Pluto isn't the dominant force, it's just one of many. The combined mass of its neighbors outweighs Pluto itself. Earth, by contrast, dwarfs everything else in its orbit. The IAU's rule highlights this difference, making Pluto's demotion a scientific correction. Pluto became a symbol of how science evolves, even if it means breaking hearts. Pluto's demotion didn't make it less fascinating. It's a geologically active world with mountains of water ice and vast nitrogen plains. Its young, crater-free surface hints at internal heat. Pluto's thin, changing atmosphere and 5 moons make it a complex mini-system. Far from a frozen wasteland, Pluto is dynamic and mysterious. Its features rival those of planets, challenging our expectations. Pluto's story reminds us that labels don't define a world's wonder. No matter its category, Pluto remains one of the solar system's most intriguing places. Pluto may have lost its title as a planet. It has gained a new one. It is the undisputed king of the Kuiper belt. Pluto is the largest member of this vast zone of our solar system. This region is home to countless icy worlds, and Pluto is their prototype. Studying Pluto is about understanding an entire class of objects. Pluto is our gateway to understanding the formation of these distant realms. Before we visited Pluto, the Kuiper belt was mostly a theoretical concept. Pluto has given us our first close-up look. It has revealed that these icy dwarf planets are not simple, inert snowballs. They are complex worlds with active geology, varied surfaces, atmospheres, and moons. Pluto has shown us that the recipe for making an interesting world is not limited to the inner solar system. Even in the cold and the dark, nature can create places of stunning complexity and beauty. Pluto provides the context for all future discoveries in the outer solar system. It has transformed our view of these distant objects into being real places. Pluto was once the smallest and weirdest of the planets. Now it is the largest of the dwarf planets. It is a king in its own right, reigning over a dark and icy kingdom. The story of Pluto is a remarkable journey that begins with a hunt for a mysterious planet X. In 1930, a young astronomer spotted a tiny moving dot, our 9th planet for decades. But science evolves. As our tools became more powerful, our understanding of Pluto began to change. The discovery of the Kuiper belt revealed that Pluto was not alone. This forced us to ask, what truly makes a planet a planet? Pluto was placed into the new category of dwarf planet. This journey is a perfect example of science in action, showing us that our understanding of the universe is always evolving. It is a story about how our picture of the solar system grew richer and more complex. The reclassification of Pluto fundamentally changed our perception of our cosmic backyard. For a long time, we pictured a relatively simple system. The debate over Pluto and the discovery of the Kuiper belt shattered this tidy image. It revealed that our solar system has a vast and populated third zone. This new picture is far more interesting, a place of incredible diversity. Pluto is the ruler of this third realm. Its story has opened our eyes to the complexity of the outer solar system. The visit of the New Horizons spacecraft was the spectacular confirmation of this new reality. It transformed Pluto into a living, breathing world. It was a world of shocking complexity and beauty, a place that challenged all our expectations. Ultimately, the story of Pluto has made the universe a much bigger and more exciting place. Pluto was just the beginning, inspiring a new generation of explorers. Even though the official decision was made in 2006, the debate over Pluto is far from settled. For many scientists and a large portion of the public, the emotional and historical connection to Pluto as the 9th planet remains powerful. This ongoing argument highlights that classification often involves human interpretation. Many planetary scientists continue to reject the IAU's definition, favoring a simpler geophysical one. Under this definition, if a celestial body is large enough to be rounded by its own gravity, it should be called a planet. The debate continues, a healthy discussion about how we make sense of the cosmos. Pluto, the little world that sparked a big debate, remains as captivating as ever.